Hey, welcome back. Unlike Java, C#, or Python, collections in JavaScript were limited to arrays and objects until the introduction of sets and maps in ES6, and that's actually the topic of this part of the series. So, what is a set? Similar to arrays, sets are basically ordered lists of elements, but unlike arrays, sets don't provide indices for their elements nor allow their duplication. To create a set, we need to instantiate it from the set class using the keyword new. That done, now we have an empty set. To fill it with elements, we need to call the add method on that instance. Every time this method is called, it returns a new set with the new value, which makes it possible to chain call add without the need to keep typing the instance name to stack other elements. Again, adding an existent element to the set will be ignored. However, if we change the type of the argument, the set will accept it because, like a triple equals operator, it compares the value in its type before it decides to accept or refuse that new value. To check if a value already exists in a set, we need to use the has method. To remove a given element, we need to call the delete method. Furthermore, we can empty the set from all its elements by calling the clear method. To get the size of that set, we need to use the size property. So here the size is 0 because we are calling the clear method right before checking the size. So removing the sixth line, we get 4, which is the total number of elements within our set. We have the ability to initialize the set with values. To do that, we need to provide an array containing those initial values. As you can see, the constructor took an array with some duplicated values, it removed the redundancy, and then returned a set. So we are basically transforming an array into a set. That being said, the opposite also can be done through the spread operator, which means that we can transform a set into an array. Now, if you think about it, we can actually remove duplicates from an array by transforming it into a set, then transform it back into an array. You might be wondering, if sets don't have indexes for their elements, then how could we fetch data from them? Well, to do that we need to use the forEach method. ForEach uses a callback function which takes 3 arguments. The first argument is the value of an element during an iteration, the second one is the key of that value, and as sets don't have keys, the key has the same value as the first argument. The third argument is merely the set from which the forEach method has been called. As you can see in the first iteration, value equal to 0, key also equal to 0, and the color is of course the set itself. In the second iteration we have value equal to 8 because the second 0 is removed. Suppose we have a set that we want to fill with a couple of variables, each containing an object. Now let's say we are done working with those variables and decided to change their values. As you see here, even if we change the values of the obj1 and 2, their initial values are still present in the set. This sounds normal, especially that we are working with arrays the majority of time, and as you know, they share this same behavior. However, that actually can be a source of performance problems in bigger applications. Imagine a scenario where we have thousands of objects that should be passed to a set. However, the values of those objects are needed just for a certain part of the code. That said, keeping the set with that huge amount of objects thereby in the computer RAM will be such a waste of resources, which is often referred to as memory leak. Here is an example. Say we have to fill our set with 50k objects. Now, those 50k objects are taking space on my computer memory even if I'm actually using none of them further in the code. So, to prevent that from happening, ES 2015 came with another type of sets, which is the weak sets. A weak set is a set that accepts only objects as values. Furthermore, a weak set will hold onto an object as long as it is bound to another reference. We can use the add, has, and delete methods on weak sets. However, they don't have a size property, neither a for each method. Let's change the set into a weak set. As you see, the instance is empty now, because we got rid of the references included in the variables obj1 and 2. That said, let's try to keep the reference in obj2. And now you see that it is back to the weak set. Now, when it comes to the 50k values in this loop, during each iteration a reference is set to the obj variable temporarily. It passes it to the weak set. Then that reference gets garbage collected, aka removed from the memory, because it is replaced by another reference in the next iteration. Thus, the weak set is merely getting rid of each newly added object once its reference is gone. The second type of collection introduced in ES6 is maps. They are a bit similar to objects since they hold their elements in a form of pairs of a key and a value. The main difference though is that keys in a map could be any type of data. So to create a map we need to create an instance of the map class. To add an element we need to call the set method and then pass the key and the value as arguments. When called, set fills the map with a key and a value and then returns a new map. Thus we can do a call chain of the method. Like sets, maps also have a has method to check if a certain key belongs to the map. To get a certain value from the map, we need to use the get method and pass the key as an argument. Again, like sets, maps also have a size property, a delete and a clear methods. We have also the ability to transform a map into an array using the spread operator. Notice that the result is a two-dimensional array that has each pair of key and value as a subarray. We can also initialize the map with some values. To do that, we need to pass a two-dimensional array to the constructor with each one of its elements containing a pair of a key and a value. Now, same as we did with sets, to fetch data from a map we need to use the for each method. The only difference here is that the key argument returns each key of the map instead of the value, because a set doesn't have a key so it got replaced by the value. However, maps do have keys, so it's logical to return them instead of the values. So at the first iteration, value returned value 1, which is the value of the first element that we used to initialize the map with. Key is equal to key 1, which is obviously its key, and then the color of the for each method. The rest follows the same logic. Pretty much similar to sets, a map is made in a way to prevent the references of the objects set as keys for its values from getting garbage collected. So again, if we set an object as key to this map and then delete the reference, as you see the map keeps holding the reference. That said, to prevent a memory leak we can use weak maps instead of maps. Now, looking at the body of the weak map, you see that only the obj2 is still in it, while obj1 is removed because its original reference is lost. Weak maps also have a set, has, get, and delete methods, but they don't have a size property, neither a for each or a clear methods. And again, once the only reference to the object set as key is lost, the map will get rid of it. And this is it for this part of the series, so make sure to subscribe and I will see you in the next one.